Hi everyone, I'm Anita Huang Tashima with the Blueprint team. I'd like to welcome all of you to today's Architecture Preview talk on Watson Explorer Part 2, Content Analytics. Our speaker for today's call is Todd Leba, a CSM with Watson Innovations Group. Amit Saha is also on the call to help moderate the online chat while the speaker is presenting. So if you have any questions during the presentation, please post them in the online chat space of the web meeting, and he will address them. The online chat will also be saved and posted after the call. This call is being recorded. I'll post the replay of the call and the online chat transcript on our Blueprint site shortly after the call. The charts for today's call are also posted there, and the link to the charts and replay is included in your meeting notice. I will now hand the call over to Todd. So Todd, please go ahead and thank you.
Okay. Hello, everyone, and thank you for joining. My name is Todd Leba. Again, the Senior Architect for the Watson Explorer Content Analytics product, and I'm a part of the Watson Innovations and Solutions Group. And I'm very excited to share with you some of the advances we've made in text mining. I have a few charts that I want to spin through, but I'd like to spend most of this session in actual demo of the capabilities of our content miner. And with that, first, let me start when most of you think of Watson, you think of the Jeopardy challenge and how Watson was able to enter into a question and answer, or actually an answer and question, kind of interface with the computer, and was actually able to beat the grandmasters. What I'm showing here is actually, there are many different ways to interact with the computer when processing large amounts of text. And this is a different approach. It's more about text mining as opposed to asking questions and getting back intelligent answers. And text mining still, very much like data mining, can provide a tremendous amount of insight into the text and still gain those kinds of answers that you're trying to look for. And so I hope to spend most of the demo in conveying that kind of approach to you. Now, the Jeopardy challenge was actually in 2011, but the content analytics product has been around since, actually it started in 2005 with IBM's enterprise search product called OmniFind. But IBM quickly found out that enterprise search was becoming very commoditized, and that what actually differentiated IBM was our text analytic capabilities. So it's around 2007 that we spun off a separate product called IBM OmniFind Analytics Edition, and that's where we injected into the enterprise search product the UEMA pipeline that enabled us to plug in various text analytics that were being developed and worked on in IBM research, as well as injecting the Sakami technology, which is really the essence of text mining. So it's that technology that we merged with the enterprise search product. And as you can see in this chart, that the analytics edition sort of worked in parallel with our enterprise search product, but it wasn't until around 2012 that we decided to merge those two, because search is still very much a part of processing natural language and finding documents and doing NLP kinds of processing with millions of documents. So we combined text mining experience with the enterprise search product in 2012, and it was in 2014 that we were joined the Watson Group and became a part of the Watson Explorer brand. And that's where Stan Bolesky presented the Watson Explorer part for the Enterprise Edition, which still addresses the enterprise search market and provides the aggregation of information throughout the enterprise and presents it in a 360-degree view. What I'm going to present here is the content analytics side of that, which is really our text mining experience, and it's offered through the WEX brand as the Advanced Edition. And so with the Advanced Edition, you still get the Enterprise Edition capability, the Enterprise Search capability, but you also now get all of the content analytics capabilities and text mining features as illustrated in the bottom half of this diagram. Now, another key feature to note here is that there are a lot of integrations that are with other IBM products that are capable through the Advanced Edition, the content analytics piece. And namely, they're listed at the bottom here, namely the IBM WebSphere portal. We have scaling through IBM's Big Insights with Hadoop technology. We're a part of the counter fraud solution, and also have integrations with Content Manager, and also integrate very tightly with other products like SPSS and Cognos for reporting and such. The key here is that the text mining experience is all about discovery, and once you discover insight into your text, the next step is what do you do with that insight? And these integrations offer many different channels of what those next steps are. For example, if you might discover a particular quality issue with your product, you might launch a case that involves investigating that particular potential quality issue. And so that would start a whole workflow process with Case Manager, for example. Now, text mining experience we view as a sort of an evolution from moving from enterprise search, which we started in 2005, as I mentioned, and moving through and adding additional value. Search is all about finding documents that you know exist, and you form your query with specific keywords to help you find that document, keywords that you know or hope to know that the keywords actually exist in those documents. But the text mining experience is really about going beyond that and opening up the content and performing text analytics and natural language processing, much the same techniques that were used in the Jeopardy challenge, but to do the kind of text mining or similar techniques like you normally would do with data mining, identifying trends and patterns in the text that can help alert you to particular quality issues or customer problems, and I'll show you many examples of this in the actual demo. We also view it as the stepping stone towards cognitive computing in the sense that text mining is a statistical approach to processing text. So there's no machine learning at this point in being able to mine. And there are some advantages to that because it's really just a matter of pointing our crawlers to the content, ingesting that content, and then letting the mathematics run against the text, identifying through various visualizations, gaining insight from what's inside that text. The next step is the actual, I'll say the cognitive computing, where you use techniques, different techniques like machine learning techniques to help learn what might be in the text and what it is trying to tell you. So it's sort of the next level of cognitive computing. But generally when you're in that area, you're now into a machine learning training mode where you're training the system to recognize these various features and facets and relationships in the text. And just as an example, for the Jeopardy challenge, it took 4 years to train the system. We've been able to reduce that machine learning time dramatically down to just a matter of months, and are trying to get that even to a shorter time frame. So it's sort of this sort of maps out the journey of moving through search, text mining using statistical approaches to understand what's in the text, and then moving on up into the cognitive computing. Now, for the content analytics product itself, it offers a text mining experience, and it's really comprised of these three major technologies. Enterprise search, which is the backbone of the engine itself and where it started from. We bring in the text analytics, which is the various algorithms and techniques for identifying entities in the text and adding semantic meaning to what's discovered in the text. But the more important piece is this business intelligence slice in the upper right-hand corner. It's the ability to leverage those text analytics and what was found and surface through various techniques different trends and patterns and kinds of insight that can be derived from the text without actually having to read it. And also without being flooded with all this noise. I mean, if you can imagine, natural languages can be very verbose and ambiguous, and the whole emphasis on text mining is to be able to sort of cut through that and separate the signal from the noise, if you will. And you'll see examples of that in the demo. So before I start the demo, I wanted to just review some of the major technologies that are being used in the text mining experience. And the first is classification, or sometimes referred to as categorization. And this is where you use supervised training techniques like a Bayesian classifier. But the point is, you don't really have to generate rules to say, oh, if you see these words in these documents, then classify it as spam or as a legal document that I need to keep for records management. You just present the system a set of documents that you feel are related to a particular category, and then you label them. And then you can have as many categories as you want, up to, like, say, 10,000 different categories. And the computer will start to learn that from the sample documents that you show it, that if it sees another document that's close enough to it, it will categorize it correctly. And actually, it will give you a score and tell you how well it thinks or how confident it thinks it is in categorizing it in the way that you trained it. Then you can decide whether to accept that classification or not. But that's a very useful technique for letting the system automatically segregate the content into predefined classifications or categorizations. The other main technique that we use is clustering, and this is an unsupervised training technique. There are no sample documents that you present to the system for it to categorize them. You let the system examine all of the words in all of the documents and identify how the documents, the words inside of them, are clustered together. So documents about a particular topic, let's say automotive repair, will use certain words that are very unique to automotive repair as opposed to, say, heart surgery, which is an obvious dichotomy. But the point is that the computer will actually identify how these documents should be grouped or are naturally grouped based off of the way the words, the kinds of words that are being used and how those words are co-located to each other, within a paragraph or a page. And you'll start to see this graph shows an example of how the documents themselves will start to form clusters. And the content analytics and the text mining experience automatically does that for you and reveals these clusters, and it's a really quick way to get an understanding of what millions of documents that you might have ingested into the system, what they're talking about, or how they're actually organized in groups. And I'll show you an example of this in the demo. The other piece or technology that we have is sentiment analysis, and this is where in the text the analytics tries to identify the user's sentiment or the author's sentiment, whether it's positive, negative, or ambivalent. And this is very useful in gauging, say, your customer sentiment about a particular product or a marketing campaign that you may have, or maybe just analyzing what's out on social media. Sentiment analysis is key there because that's where the buzz is occurring, and you have the ability to crawl content on social media, bring it into content analytics, and perform a very robust set of sentiment analysis. And I have an example also in the demo that will show you what kinds of visualizations we provide on determining what that sentiment is in the text. Another main technology that we have is what's called concept discovery. And what this does is it looks at the words that are used in the documents and tries to tag the document with higher-level concepts that represent what is being discussed in the text itself. Now, there are two techniques that we use. One is the Alchemy API. Alchemy is a company that we just recently acquired. There you give it, Alchemy, the page of the document or the entire document itself, and it will return the top 100 concepts with that. So if it's, if it's Hillary Clinton talking about, her tenure as Secretary of State, then it may tag the document with concepts like Secretary of State and the United States and United States as a geography and so on. There's also another technique that we use where we've leveraged the WordNet lexicon, and there are many other similar lexicons that will return what are called hypernyms. And a hypernym is just a more general term for a word. So if I have the word in the text, for example, melanoma, then the hypernym for melanoma is cancer, and a hypernym for cancer would be a disease, and so on. So this way you can start to build a hierarchy, almost a tree-like of concepts. At the various high level of the tree would be the most general concepts, and you can sort of browse through the content at this conceptual level and not actually have to worry about the specific keywords and all. And again, I have an example of this as well. And this is a visualization of the concept discovery, but I'll defer that until the actual demo. Another key technology in the text mining experience is leveraging ontologies, and the way we do that is we're now supporting the resource description framework, which is a standard way of representing knowledge in the form of what are called triples. And so when we all talk about text and sentences, most of the time a sentence can be broken down into its basic components, which is what is the subject of the sentence, what is the predicate, or the predicate is the verb, or the action verb of the sentence, and then who is the receiver of that action verb? That's the direct object of the sentence. So those three components together form what is called a triple, and the resource, the RDF standard actually is a consistent way for different vendors to represent this information that's being encoded in this triple form. And so once you've distilled the sentences down into their triple and basic form, there's a whole slew of kinds of analytics that can then be applied, because now you're just operating on triples. So if I had a statement like Obama voted for the energy bill, that's a triple. Obama is the subject, voted is the predicate, and energy bill is the direct object. And now if I had another sentence that said the energy bill became legislation yesterday, that's a triple itself. Those two triples are now linked together by the energy bill itself, right? So you can see now that you're now operating on triples very much like you would in SQL, where you can now do joins on the triples themselves. Very powerful way to process text, not get all tangled up in the sort of the verbosity, if you will, of natural language and how complex it seems when you sort of just filter it down and break it down into a triple. It's much easier to process. And we'll get into that in the demo as well. And then lastly, and you'll see this throughout a lot of the demonstrations of the text mining, and what we feel is one of the biggest differentiators for us is the correlation analysis on textual words themselves. And so what this means is correlation is very similar, when you have two different sets of data, you want to understand if they're highly correlated to each other. It also can apply to things in text where words themselves tend to be highly correlated as well. So a good example may be like if you're talking about cigarettes or smoking, then other words that are highly correlated to that tend to only show up when you're talking about cigarettes and smoking is like lung cancer, right, or other words similar nature. So that correlation analysis is extremely useful and generally applicable to finding insight throughout your corpus depending on what subsets of documents you're comparing to. And you'll see this demo as well. And actually, we should just get into the demo now and demonstrate that capability. So let me switch over. Okay, so before we start into the text mining experience, I have several data sets that we're going to actually analyze. And the first one that we're going to look at is a data set of MedWatch forms, and we have like over 3 years worth of MedWatch forms that we're going to look at. And the MedWatch forms are administered by the FDA, and the FDA regulates not only food and drugs, but also medical devices. And whenever a medical device, like an X-ray machine or a CAT scan or even a pacemaker or a thermometer even, if there's an adverse event, this is what the medical teams refer to it as, a problem with a device, then the hospitals are required to submit to the FDA a MedWatch form describing the problem. And this is a facsimile of a MedWatch form. There's structured information that appears at the top of the form, like patient information, which has been redacted out of this example, the brand name of the medical device, the manufacturer of the medical device, the type of medical device. But eventually you get down to the unstructured portion of the form where a hospital just enters in free-form text to describe the medical problem. And what we're going to do is analyze these. Whoops, actually, let me reset this here. Okay, so, actually, I got to log in too. Hold on. It timed out while I was talking. Let me switch to FDA. Okay, so this is our content miner application, and it appears similar to like a search tool. It does have a search box at the top, and you can type in any search query you'd like, and we have a very robust syntax that lets you do that. But we have many other easier ways to drill through the text. I mean, search was a traditional way to process text where you would just type in words that you think might exist in the content and sort of poke and jab at the text to see what you come up with. But this text mining experience is sort of the reverse. You want to let the statistics surface to the top, the words that are maybe statistically relevant or important for you to focus on. Now we're looking at roughly 3 years. Well, no, actually, let's see. It's actually from 2012 to 2015 of MedWatch forms, and there are 201,958 of these MedWatch forms. And off to the left here, for the content miner, there are many different visualizations that we offer here for you to look at. And we'll get to most of these in this demo. Off to the left here, we have what's called our faceted navigation panel. And a facet, a different way, using either metadata or text analytic derived values, a different way to sort of drill into the content and get different perspectives on the content. Now, we have facets here, for example, for the MedWatch data, device information. We have a facet for the brand name of the device. I have a facet for the type of the device. And for each facet that I click on, and right now I'm on the particular type of medical device, each one gets its own line. There's a fluoroscopic X-ray here. There's infusion pumps. There's intraocular lenses. And each one shows me the frequency and the correlation. So, for example, fluoroscopic X-ray, there are 14,091 adverse events for fluoroscopic X-rays. And right now the correlation is set to 1 because we're not actually comparing it to something. So we're going to actually process and see if we can identify some particular adverse events that are occurring. And we're going to switch over to the trends view. And we're still on the type of medical device. So each type of medical device gets its own time series chart, and the time series chart is showing the frequency of adverse events, the number of forms that were submitted to the FDA for that particular device. Now let's say I'm a subject matter expert at the FDA for infusion pumps, and I want to see what adverse events are occurring for infusion pumps, and I found that particular chart. We're going to zoom in a little bit more. Now here for infusion pumps, there are 1,703 adverse events that are occurring for infusion pumps, and as an FDA analyst, I'm very concerned about that, and I actually see that here in September, October, and November, there was a huge spike in these adverse events that were occurring. But actually, the problem with these adverse events actually started to occur back in April of 2008. Or actually 2013. So what I'm going to do is let's pretend for a moment that we're actually back in April and we see this spike occurring. And notice that the system highlighted in red, these were statistically deviant from norm. And this is something, it's the system's way of telling you you should sort of look at this and sort of determine whether it is actually a problem. So we're going to select this and drill down into this problem with infusion pumps. We're now going to switch our facet to noun phrases, and I'm going to jump over to the facets here. Now, I've switched to the parts of speech, and what we're looking at are actual noun phrases that are occurring in the text that are right now, since we're looking at infusion pumps, these are the most frequently occurring phrases. But remember I told you that correlation analysis, this is where we'll separate the signal from the noise. Because right now with the frequency, I'm seeing phrases like medical intervention, additional information. That to me is sort of noise. But if I sort by correlation, I'm starting to see phrases like depleted battery and main battery. And as I click on these, I can see in the documents how those phrases are being used. And I see things like, the condition of depleted batteries. The infusion pump had a depleted batteries. It seems like there's an actual problem with these batteries on these particular infusion pumps. So what I'm going to do is add these to my query and drill down, and I'm going to switch over to the brand name of the device and see if I can identify what brand of the device is having these battery problems with infusion pumps. And what I see here looks like 6 different brands, but they're actually the same one. If I look closely, it's all about the Colleague triple channel volumetric infusion pump. Now, we could have written a dictionary that if I see this particular brand, and these are different ways of spelling it, the hospitals use different abbreviations and such, it looks like it's 3. But I can visually see that they're all the same problem with these batteries on the Colleague triple channel volumetric infusion pump. And if I switch over to the manufacturer facet and select that, I can see that it's one manufacturer, the Baxter Healthcare, which seems to be having this battery problem with their Colleague triple channel volumetric infusion pumps. Now what I'm going to do is switch over back to the presentations. And what I want to show here is that later, a year later, the FDA actually did a recall on the Baxter Colleague triple channel volumetric infusion pumps, and the reason for the recall was damaged batteries. And what's even more interesting is a year after that, the Baxter Healthcare manufacturer actually decided to recall all of their Colleague triple channel volumetric infusion pumps, and it was a cost to them was $400 to $600 million. So you see that with the text mining experience, just with a couple clicks and letting the sort of the correlation analysis surface to the top, keywords that were actually indicating that there was a battery issue with this, Baxter could have caught this problem earlier and maybe corrected the problem and prevented the actual recall from happening. Now, actually, Baxter is a customer of IBM's, and they're well aware of this technology. Let me switch back to the demo. Now, what I'm going to do is switch over to our department, our DOT data set, and this is the National Highway Transportation and Safety Administration. They have a program where people can submit automotive complaints to the NHTSA, and it's a public website that you and I can go to, and they'll record any problem that they have. And what we let me get some settings here. What we're looking at is 1,053,494 automotive complaints ranging from, let's see, all the way from 1998 all the way to 2015. And we're going to actually text mine and look at this content similar to what we did with the MedWatch forums, but we're going to use different visualizations and techniques to reveal particular automotive issues or quality issues or safety issues with different automotive vehicles, makes and models. But before I do that, I want to show some different facets here. One of them is we have a source facet where we actually ingested content from two different sources. There's the actual NHTSA complaint forms, which we've ingested, and that's the bulk of the million documents that we're looking at. There's 980,000 of those. But I also crawled the Edmunds.com automotive website, where they have a blog or a blogosphere there that you can start a blog on any issue, and there are quite a few blogs that are related to different makes and models of cars or different issues that people are having. So I thought, well, that's similar to what I would do with NHTSA, but it's so why not just sort of crawl that data as well and join them together. What's nice here is I can select one and actually filter down to just those Edmunds documents and analyze them, or I can go and analyze just the NHTSA documents as well. Another facet here that's worth mentioning is this weather facet. This was not a structured field that came with the data. This weather facet was populated with values that were determined using text analytics. So let me click on this rain facet. I'm going to expand this to 100 values. And what we see here is, obviously, we see different mentions of the word rain. I can see raining, rains, but also I see words like drizzle, and then further down here I'll see words like downpour, and what I think is really interesting here is flooded. That in this case here, the passenger side of the car got flooded. But what's interesting here is the text analytics that I wrote for this to identify weather conditions was, I wrote a rule that made it smart enough to know the difference between a flooded creek bed and the car getting flooded inside versus a flooded flooded engine on gasoline. So the text analytics actually improves the accuracy of what you're looking for, and I sort of certified that as a facet that allows me now to drill down into particular automotive issues or complaints when it comes to rain issues. But when it's raining outside, some cars may have a harder time with their brakes versus other automotives or other cars. So that's the value there. Now, the other facet that's interesting is this cluster facet. And remember earlier I was talking about clustering, where it's unsupervised, natural the system figures out how the words are naturally grouped together and clustered together. And what it does is it will pull out clusters as they form and label them with the top 10 words that make up that cluster. So, for example, here's a cluster with the words tread, tire, belt, tires, separated, firestone, blew out, rubber, separation. Now, it's ironic that little cluster right there nails it when, if you all remember about, I think 5 years ago, maybe more, Ford Motor Company was having trouble with their Firestone tires that they had on their Jeep, Grand Jeeps. And mostly in hot weather, the treads were separating off of those Firestone tires. And so a lot of people were probably complaining about their tire separation and submitting complaints, and this cluster just naturally surfaced. So this is, I mean, you can see other clusters here, like here's one, airbags, deployed, physical hit, smashed bags, airbag pulled. I mean, these may be issues with airbags, or maybe they were just commenting that the crash was up that the airbag went off. But again, the system was able to sort of cluster these into organized groups of documents that allow me to sort of say, oh, I have a tire tread separation problem. Let me select that, drill down into that particular cluster, and then I can come back over here and see what the manufacturer is. And sure enough, there's Ford Motor Company and Firestone at the top of the list. And then I can start looking at my other noun phrases or different phrases used in the text, and I might learn some more information about that particular clustering. Now let me switch to another view here. I'm going to switch to our facets pairs view, and I'm going to use our model. Let me break this out again. And okay, so what our facet pairs view does is it allows you to compare two facets. And you could select any two facets here on the left to be compared, but what I find the most insightful is to take a structured field, like the model of the car, is listed across the top of the spreadsheet here, if you will, and then down the left side is the actual noun phrase, which we used earlier to help us gain insight into the text itself. And just as I mentioned before, the color coding is important here. It's where the system is identifying highly correlated terms or noun phrases that are being used for a particular model. Like here, the TL has a failure in mileage, and I can sort of scan around. This is almost like a heat map. I can sort of scan around and look for different problems here. And let's see, for example, let's see if I find... well, here's, let's see, like here's the Cooper is highly correlated. It's the passenger side tire. I might go down further, and I see here Steel TX Radius Firestone. It has a particular problem. I find here that the TL had a tire failure at certain mileage, and I find these particular facets here. Oh, actually, let me, I see what's going on here. I need to reset the query here. This is much better. Okay. So I had the previous term from the tire separation. That's why I was getting different values here. But I'm now reset the query looking at everything, and I see that the Dakota has a highly correlated term to ball joints. And ball joints are the steering mechanism of the car, and it seems like the Dakota has a ball joint problem, and I can click on this and drill down into it, and then we can actually start to look at the documents for these, and it actually highlights the Dakota and the mention of the ball joints, and I can start to get a feel for what's the problem with this Dakota and the ball joint problems that it's having. Again, with just a few clicks, I'm able to gain that kind of insight into the text using this sort of heat map that lets me see very quickly where this highly correlated phrases are being used for particular makes and models of cars. Okay, so let me switch to another data set here. We're going to look at employee survey analysis, and we're going to use the sentiment analysis component here. And what I'm looking at are 12,374 employee survey responses. This is the DoD. The information here has been de-identified. And the facets over on the left, some of the structured facets that we have are like the age of the participants, the sex, the race, the education, their pay group, being the armed forces, what section of the armed force, which armed force were they a part of, was it Army, Navy, Air Force, or the Marines? And for any one of these facets, you can start to see the separation of the positive comments, the negative comments, and the ambivalent ones. So, for example, for this age group, 50 to 59 years, when I select it, I can now see their positive expressions, and they're all listed here. And I can click on this particular phrase and see, oh, I love my job, and I can actually look at the comments in the text and see how they express, I love my job. I've been working here for so long and such. But probably more important in a survey is their negative expressions. So I can click on the negative expressions, and I can see all the different negative phrases that they're used. And here's one like, the system is broken. And I look over at the text, and it says the hiring system is broken. We should measure announcement, screening, and hiring in weeks, not days, and so forth. So I can very quickly see for a particular facet, and in this case we're looking at the age of the individual, I can start to see where or what their sentiment it is, and how they're feeling, whether positive or negatively. Now, the other feature that we just added recently is with our deep parsing natural language processing, we're able to also not only identify positive and negative terms, but also the target of that sentiment. So what I'm going to do is switch here to the target of the sentiment. And what is listed now at the top here is the targets of their sentiment, and this is for the age group. So for example, the system, this looks sort of evenly positive and negative, but notice the job sentiment, their sentiment expressed towards the job itself, very positive, right? It's almost 92% versus 7% negative. And I could click on that and as well see the actual positive expressions here and what the negative expressions, and maybe I see the word difficult. I can find out what is actually difficult, what their negative sentiment is. Now, sort of the reverse of that, I can also switch this view to actually look at the expressions themselves. So the sentiment expressions themselves. So I see the word good, which is a positive expression, of course, is the most frequently used expression. But I can see that difficult was another negative expression, and I can drill down into that, see what the targets of using that word, when they're saying difficult, what was difficult? Well, the survey was difficult, or the system, or the process was difficult. And I can see how that's used. Now, you could imagine that maybe you have customers that have surveys on their particular products, or just customer feedback that they get on their products. Could use this text mining technique to very quickly understand what they're, not only whether they're happy or sad about a particular product, but also what it is they're actually angry about or not happy with. And then, so that's our sentiment analysis. And lastly, I'm going to switch over to our news story analysis. Oh, and actually I have a different view for that. Let me refresh this because I know it will time out. Okay, so this, what we've done here is we're analyzing over 1,815 news stories, and these were crawled from CNN.com, New York Times, and Washington Post. And we used the concept tagging that I described earlier using the Alchemy API or the WordNet lexicon to tag these news stories with higher-level concepts so that I can actually explore what those concepts might be. And what we're looking at here is, remember I mentioned that the concepts are hierarchical. More general terms would be at the higher levels, and at the bottom here on this grid, the concept level 0 is the highest level, and concept levels 1 and 2, which is what we're only looking at right now, is level 0, 1, and 2, and 3. And we're looking at those, and I can sort of scan around, and I see, well, there's a higher level concept here called issues, and stemming from that, the lower level concepts are issues like abortion, same-sex marriage, healthcare, natural resources. So I can quickly sort of scan through and see what all these different concepts are that are expressed in these news stories. Now, let's say I'm interested in in news stories about the political parties. I can actually search for that concept, and I see that it's highlighted it. And when I add it to our query and focus on just those news stories about the political parties, I see things like, well, here's a news article on Mark Sanford. I see an article on the RNC, GOP primary debates. These are all news stories about political parties. And off to the left, you notice that our concepts have been reorganized and just focusing on these documents, the concepts that filter in there. Now, remember I talked about the color-coded, the way the system color codes. Well, what it's coding the actual concepts, both with in the size of the concept, the circles that you're seeing, the more highly correlated they are, the bigger the circle and the darker the color. So the most highly correlated ones, like here's political parties, I see groups, I see state officials, Republican governors. All of these are highly correlated. Now, my slider here, I can actually look at the other less correlated concepts by dragging my slider down into the gray area. And now you see some other white-coded, white-colored circles like celebrities, celebrities and Donald Trump. That sort of makes sense. But if I want to cut through the noise and focus on the most highly correlated concepts, I can move my slider further up and just focus on those concepts and sort of separate the signal from the noise, if you will. Again, a very quick way to sort of navigate through large numbers of documents and content and able to quickly understand what's going on at a conceptual level, with these different concept tagging, or at a highly the correlation or the cluster analysis that we use to identify what are people talking about, or what are the documents trying to say. So with that, I'm done with the demo. Let me switch back to the presentation here. And actually, I had two other charts, I thought I did, that were about the scaling options here. With content analytics, I just want to mention that since we've been around for over a decade, we've learned that one of the key tenets of the product and the design points is that it's extremely easy to install, that there are no prereqs involved here, and you can download this from Extreme Leverage, install it onto your laptop, and with 3 clicks have it up and running, and then start pointing to a website, crawling data, start doing the kinds of text analysis that you saw in the text miner. But beyond that, this is also designed as an enterprise-grade application and can be deployed in a big way in organizations. And there you can use different scaling options. We have 2 scaling options. You can add additional servers to handle the additional indexing load and the document processing load, maybe the crawler load. Usually we don't see the crawlers as being the problem. And you can also add additional servers for the search runtime. But you could also run this on Big Insights in a clustered environment, which is where you can leverage the MapReduce processing that occurs in Hadoop. This is what Google uses when they are building indexes of massive size to support Google search. You could also deploy this on that scale and actually do this kind of text mining in a big data kind of way. So with that, I'm going to conclude the demo and the presentation. I just want to remind you that this is a different approach to natural language processing and text processing. It's statistical in nature. It allows you to sort of ingest your content and get running very quickly and sort of provides you the entry ramp, if you will, to your cognitive journey where you start employing other techniques like machine learning that will get you into the more of the question and answering dialogue kind of session where you want to just ask the computer what is wrong, and it hopefully would respond with an intelligent answer. So with that, I know I'm a little short on time here. I'm about 10 minutes early. Do we have time for questions? Or
yes. Yeah, we can open it up now for verbal Q&A. So if you have a question for Todd.
Actually, Anita, I need to unmute the phone lines. Can you hold on one second?
Sure.
Okay, I'll be right back.
Would you like your guests to... All guests have been muted. You will now rejoin the meeting, your line, by pressing *6.
Okay, I'm not done. Give me one
Okay.
second.
All guests have been muted. You can unmute your line by pressing star 6.
Okay.
Okay, so if you have a question for Todd, you can ask it now. Just press star 6 to unmute your line. Again, press star 6 to unmute. What you could do is, Amit, if you see any questions in the online chat that you think is worth highlighting on the phone, you can raise those as well with Todd.
Hi, Todd.
Yes.
Quick question. First of all, thank you for the presentation. It's phenomenal. So, in terms of the data, is there any restriction or limitation on the amount of data that can be processed concurrently?
Well, we're always working on that. We're up to about in the hundreds of millions, roughly I'd say around 200 to 300 million, and we have several customers that are operating at those levels. Obviously, it takes multiple servers to do that. Our biggest customer has 28 servers at the moment, but it's interesting you say that because with our next release, we're planning in the end of somewhere in 2016, we're hoping to support 1 billion documents because we're now getting requests on the big data scales, if you will. The product has done very well. Most of our customers, we have quite a large number of customers, but most of them operate within the millions of documents. I'd say up to about 10 million or 20 million. But just recently, we've been starting getting requests for massive amounts of text on the order of hundreds of millions and reaching close to 1 billion. So yes, that's what we're working towards, and we can easily support. That's why at the end of the presentation I was trying to I opened to present some charts on our scaling options, because when you get into text analytics and the types of processing that's involved, it is very compute intensive. And it's much more so than the traditional structured number crunching that most customers are familiar with. So we've been dealing with that for over the years and sort of evolving along with the trends.
Perfect. Thank you.
Hi, yes, this is Aaron Labella. I have a question. Can you hear me?
Yeah, sure.
I've been working with Watson Content Analytics for, 6 months or so, and I was just wondering, maybe I missed it at the beginning, and if I did, I'm sorry, but can you talk about the products? I'm kind of curious, is Watson Explorer kind of superseding WCA, and, that's where all the new functionality is going to?
Well, we joined Watson in 2014, and we joined in at the Watson Explorer brand. So we are a part of Watson Explorer, and I think in that chart I showed you before, bear with me.
So, what I'm really curious about is, what is the difference between Watson Content Analytics and Watson Explorer? And should our efforts be going towards Watson Explorer, since it seems like that basically encapsulates all the functionality that WCA did?
Well, it depends on the use case. Watson Explorer, and it's sort of shown here, Watson Explorer doesn't have its own, well, it does have a text analytic pipeline, but it's based on System T. But the Watson Explorer is focused mostly on the enterprise search use case and the aggregation of content. The content analytics is focused on opening up that content and going deeper into it and analyzing the content, as demonstrated in the minor.
So if you want to do UEMA, you still need WCA, and then you would basically plug the output of those collections into Explorer?
Well, there is a link there, which is shown here in this chart, where during the conversion pipeline in the foundational components, if you will, it can call out to content analytics and do the text analytics and get back the entities and relationships and whatever text analytics you identified in the text, those annotations are brought back into the search engine and can be used to annotate the documents with those results. But what the foundational components don't have is that text mining experience. And at the bottom of the chart, we have to build a rather highly optimized index for the text mining experience. So it can't leverage the existing search engine that's listed at the top. Actually, it's a different search engine. We use Lucene on the bottom, and we've modified it to include some of the, I'll say, near real-time statistic calculations that are needed to do those correlations that you saw and some of the other kinds of text mining techniques. So it really depends on the use case. Where the content analytics is more focused on the business analysts, the data scientists, those that are more like knowledge workers that are charged with identifying maybe cyber fraud or cyber security issues or quality issues or customer satisfaction issues. They're normally poring over large amounts of content text and trying to make sense out of it. On the other hand, the foundational components are more geared for the traditional enterprise search use case, where I have a huge amount of heterogeneous content scattered across the enterprise, and I need to pull that all together into a single 360-degree view and give me sort of an aggregated view of that, and almost like a dashboard in a way. So they're really two different use cases, and you got to ask yourself which one are you shooting for, with what fits best for your customer.
Okay. All right. Thanks.
Okay, there's time for one more question. If you have a question for Todd, press *6 to unmute your line.
Hey Todd, this is Lee from the IBM. This is Lee from the IBM JSTAR team. I just had a quick question. You might have covered. I joined a little late. Kind of future plans for the studio and for kind of the Watson Knowledge Studio thing that I think is getting built. Did you cover that at all?
No, I didn't even get a chance to cover that, and that's one of the things. That's an important aspect of content analytics. It served well. But what we're referring to is there is two different approaches to developing rules for text analytics. One is what we call rule-based. The other is machine learning. The Watson Knowledge Studio is currently mostly focused on the machine learning because that's the one area where we lack the appropriate tooling to develop and deploy machine learning models to the engines like WEX itself. The Studio has been around for years. It's an Eclipse-based workbench that allows you to very easily, we've been very successful with it. Business analysts, business users who are not computer literate that much use it quite frequently and very successfully in building dictionaries and building rules to identify entities and relationships in the text and such. There will be a merger of the same rule-based approach that is used in the Content Analytics Studio in the Watson Knowledge Studio. The Eclipse-based version will be around for a while as the WKS, the Knowledge Studio, matures. The first release is coming out, I believe, in July, but it will be a 1.0 release, so it's got some really good stuff for the machine learning. The rule-based won't be as robust as the rules development that you can do in the Studio. So the Studio will be around for a while.
Thanks, Todd.
Okay, thanks. Let's end the call here then. I see that the chat is still quite active, so I'm going to leave it open for another 5 minutes or so that Todd and Amit can finish addressing all questions in the chat space. I will then save and post the online chat transcript on the Blueprint site shortly after the call. I do want to point out that last week we hosted a call on Watson Explorer Part 1 on cognitive exploration with speaker, Stan Bielski. I've just posted a link to that replay in the online chat session so you can get to the replay from there. So again, thank you to Todd Leba for taking the time to present on this topic, and thanks to Amit Saha for his help with the online chat. Please take a few seconds now to rate this presentation. I posted a link to the survey in the online chat. You can also click the Rate This Talk button in your meeting notice to open a very short survey. You can also add this talk to your Think40 credits by clicking the Add to Think40 button on the Blueprint webpage. Again, the replay and the online chat transcript will be posted later today, and you can get to that link from your meeting notice. That's it then. The call is now ended, and thank you all for joining. And thanks again, Todd and Amit.
Thank you.